Hello, everyone. This is Shauna, and I'm coming to you in this video with two questions from the classroom about some limits. One of them comes from the review for your Chapter R exam. The other one comes from R5, the Indeterminate Forms worksheet. So let me share this at this time. This first limit that I want to address is from the Indeterminate Forms worksheet, and it reads, the limit as x goes to infinity of e to the x over x to the power of 100. Okay. And the question the student asked is, it didn't seem to match the form that he was expecting. So, and this is a little bit straightforward at the beginning. It's infinity over infinity. But then how do you deal with this bottom piece? And I wanted to remind you, so I did a little pattern down here. This is derivatives that we know how to take. Let's say we have y equals x squared, okay? I want you to notice something about the pattern here for a minute. So we take x squared, we take the derivative, we get 2x. We know the coefficient comes down, we're used to that. And then we end up with just the constant, and then we end up with 0, okay? Notice if I do x cubed, I get 3x squared, 6x, and then 6, and then 0. What I want you to notice about this is that whenever you have a variable raised to a numerical power, 3, 10, 100, doesn't matter, you have as many non-zero derivatives, derivatives that are something other than 0, non-zero derivatives as the power on that x or that variable. So when I had y equals x squared, I had two derivatives, 2x and 2, that weren't 0. When I went x to the third, I had three derivatives, 3x squared, 6x, and 6 that were not 0. Now, where am I going with this? There's a pattern not only in the number of derivatives, but in the way those derivatives come about. So if we look at x to the fifth, I did one more here. And I tried to show you a pattern. So this is 5x to the fourth, we know that. And I wrote that as 5 times x to the fourth. You'll see why in a minute. Then I took the derivative again. 4 times 5, 20, x to the third. 3 times 5 times 4, or 5 times 4 times 3, it doesn't matter. X squared, we got 60x squared. Then 2 times 3 times 4 times 5. This should remind you of something, okay? And then we got 120 and 0. Well, I can differentiate e to the x for as long as I want, and I'm only ever going to get e to the x, right? Regardless of what I approach, as long as this matches L'Hopital's rule, I can continue to differentiate e to the x, and I'm going to get e to the x as many derivatives as I take. So if I know that x to the 100 now has, remember, it has as many non-zero derivatives as the power. So we would have to apply L'Hopital's rule 100 times. We don't want to do that. That's why I gave you the pattern. This derivative, x to the 100th power, eventually, when you apply it enough times, is going to come down to 100 factorial, which is, if you remember, 5 times 4 times 3 times 2 times 1, right? All the way down, because that's what we would be doing. This is this is x to the 100. That's going to be 100 factorial. And if I'm approaching infinity, then e to the infinity power is going to keep increasing. So I'm going to get infinity, and I'm going to have infinity over this constant, right? And that's a big constant, but it's basically a constant times a number that's getting infinitely larger, and that's going to go to infinity. So this limit, this is number 7 on the R5 worksheet. This limit is infinity, okay? I hope that answers that question for you. What I'm going to do here is I'm going to do a new share now. And I'm going to bring in this other limit that I want to show you. The other question that somebody had was about number 17 from your exam review. As I mentioned, this is the limit as x approaches pi over 2 positive from the left. The limit as x approaches pi over 2 from the left of secant 7x times cosine 3x. Okay. So again, the very first thing, if you watched my other videos that I preach when we do limits of indeterminate forms, is always plug in your value or your idea to see what kind of form you're dealing with. So you have secant 7 pi over 2 times cosine 3 pi over 2. And that's infinity times 0. Now, this person didn't have a question so much about evaluating the limit. They had a question about the trig behind it. So before I go through the limit itself and the indeterminate form and how we got rid of the indeterminate form and whatnot, before I go over that, I'm going to go over a little bit of trig that we had from before. So what I'm going to do here is I'm going to bring up a graph for you that I created. Let me see here. Bear with me for just a moment. So here is a graph. This looks rather busy. I'm going to turn some of this off. This is a Desmos graph. I'm going to turn off some of this in a second. Here, I'm going to turn off the cosine. Actually, I think I'll leave those. I'm going to turn off my numbers and I'm going to turn off the secant here. And I'm just going to leave the cosine graph. Now, because of where we are, we're at the 7 pi over 2. I graphed this a little further out than I normally would. This is the graph of cosine, okay? Cosine of 0 is 1. We know this. Cosine of 0 is 1, which is this point here. Cosine of pi over 2, 0. Cosine of pi, -1. Cosine 3 pi over 2, 0. Cosine 2 pi, 1. If you don't remember these values, you can look back at your unit circle from trig. You can also plug them into your calculator. And just remember that if you want your graph to look like this looks, you'll want to either label your, put your calculator in degree mode and have it graph as trig form. Or you can put it because if you put it in radian mode, it's not going to look right. Okay. So this is your now. That's cosine. That's not secant. Okay. Cosine 7 pi over 2, 0. Why? Because cosine of pi over 2 is 0. Cosine of 90 degrees. Unit circle. If this is the unit circle, then I'm looking at, here's a circle, right? Here's my unit circle. This is pi over 2 at the top, right? 7 pi over 2 is 3.5 units of pi. So I've gone around the circle once already, and I'm going another 1.5 pi, which puts me down here at negative 3 pi over 2. Now, this graph over here is a far cry from the one that I'm showing you, but let me go back to the other graph that I had in Desmos. Here's cosine. If you get stuck graphing the secant, you can use cosine to help you. Whenever you have a 0 for any of the trig functions, the reciprocal will be undefined. So if I go back now and turn on the secant graph for you, there's the secant. And we can see that at 7 pi over 2, right? Cosine has a 0, secant has an infinity, okay? So that's where this is coming from. And then all of these multiples of pi halves, whether they're negative or positive, all of those multiples are going to be vertical asymptotes. So that's what happens with that, okay? And that's what that graph looks like. Now, what I'm going to do here is go back to our problem. And we have, let me see what I'm sharing. Here it is. Okay. Now we know that we're approaching pi over 2 from the left. Okay. So we know we're getting 0, right? We know why we're getting 0 now. So now we have the form 0 times infinity. Okay. And when we have 0 times infinity, remember the rationale, the way we approach this is to write this as a division problem. So we're going to divide by the reciprocal of one of these functions, okay? Now, the reason she chose the secant here instead of the cosine, if I had divided by 1 over the cosine, I would have been in the secant again, and I would have had cosine over secant, which would be undefined. So she elected to divide by the reciprocal of the secant. And remember, the reciprocal of the secant is cosine. So what you end up with is cosine 3x, which we had the first time, over 1 over the secant of 7x, which simplifies to be cosine 3x over cosine 7x, which is of the form 0 over 0 when you apply the limit. The limit as x approaches pi over 2 from the left is of the form 0 over 0. Now we can apply L'Hopital's rule. Remember, the derivative of cosine is negative sine. And remember, we need the chain rule. So negative 3 sine 3x. Why negative? Remember, cosine is the derivative of cosine is negative sine of x. So negative 3 sine 3x. and again on the bottom, negative 7 sine 7x. Do not cancel the x's here. These are arguments. These are not coefficients of the function, okay? This is part of the argument of the angle. So don't cancel those, you're changing the problem. And then from there, plug in again and make sure what form you have. So you plug in pi over 2, sine of 3 pi over 2. Now you're thinking about the sine. This is the sine of pi over 2 on the negative y-axis. So that multiple is going to be negative 3. And you have pi over 2, the sine of 3 pi over 2. If I go back to this, now I'm going to do something different. I'm going to get rid of my sine curve, and I will do some adjusting here. We're going to graph from 0 to 2 pi. And we're going to graph we're going to step or increment by pi half. So, and I'm going to I usually use like negative 5 to 5. That's a pretty good interval usually for that. I'm going to step by pi halves, and I'm going to actually, let me make this, just so I can see the axis, let me make this negative pi over 2, because I want to be able to see the y-axis. So let's say that I've got that, and I want to graph the sine of x. So there's my curve, okay? Now let's go back, okay? So we now have the sine. Let's focus on this sine of 3 pi over 2, okay? So let's, sine of 3 pi over 2, what is it? Well, let's go back to the graph and look at it. You've got 3 pi over 2, that's a negative 1, okay? Because you're down below the axis. If you were looking at it in terms of your, this is my unit circle. Again, I'm down here. The sine down here is a negative 1. The cosine would be 0, but the sine would be a negative 1. So here, this becomes this is missing a negative. The solution is, this is a sine of 3 pi over 2 is a negative 1, and sine of 7 pi over 2 is also negative 1. So this becomes negative 1 times negative 3, positive 3. These are negative. So this is a negative answer. Let me just fix that on screen. So the answer is going to come out the same because these negatives are going to cancel, but technically that's a negative 1. And 7 pi over 2 technically is also negative. It's coterminal with -3. So you would have -3 times -1, +3, -7 times -1, +7. So your result is still okay, but technically these are both -1s, okay? Just wanted to point that out. I hope that these two limits help you, and I will see you in my next video. Thank you so much, folks. Take care, be safe, and I'll see you very soon. Bye for now.